Hi students at home, this is Helizchem. Today we want to quickly look at likely questions that may come out in WAEC or JAM for those of you that are preparing for these two exams. What is the question? If 100 cm cube of hydrogen diffused through a porous spot in 1.0 seconds, how long will it take the same volume of oxygen to diffuse through the same pot under the same conditions? You are given hydrogen to be 1, oxygen is 16, and the options are A 2.5 seconds, B 4.0 seconds, C 16.0 seconds, D 25.0 seconds. Let's look at the solution. If you look at this question very well, you will see that this very question is based on rate of diffusion, which is Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the vapor density of the gas at constant temperature and pressure. That is what Graham's law states. So from the definition, we can infer this formula: R1 over R2 is equals to D2 over D1. When you go further, we have also R1 over R2 is equals to M2 over M1. This is equation 1. This is equation 2. Likewise, our R1 over R2 can also be equal to T2 over T1, that is time. This is equation 3. So for Graham's law of diffusion, we can combine the three equations together to have this: R1 over R2 is equals to D2 over D1, which is equals to M2 over M1, which is the same thing as T2 over T1. Are you confused? No, you don't have to be confused. You are wondering how I got all this formula. Don't worry, Helizchem got you covered. In my next video, I'm going to treat Graham's law of diffusion extensively. So just make sure that you stay tuned on this same channel, Helizchem, for the next video on rate of diffusion. So as I was saying, we are going to use this formula, but we are not using everything. Just take the one that is applicable. If you look at the question given, we are given 100 cm cube of hydrogen which diffuse through a porous spot in 1 second. That means the time of hydrogen is 1 second. So we are looking for the time of oxygen. That is what we are looking for. But don't forget, we are given that hydrogen is 1, oxygen is 16. What does that mean? It means that relative molecular mass of hydrogen is 2. Why is it 2? It is 2 because hydrogen is a diatomic, so it's going to be 2 times 1, which is 2. Also, relative molecular mass of oxygen will be 32 because oxygen also is a diatomic gas. So a single atom of oxygen is 16, So 2 times 16, that is 32. So going back to this formula now, we are going to look at the appropriate one. We are given time and molecular mass. So that means we are using this very one. This is the only one that is applicable. So we have M2 over M1 is equals to T2 over T1. Let our hydrogen, which is the first gas, be 1, and our oxygen is the second gas, which is 2. So M2, that is relative molecular mass of oxygen, which is 32, square root 32 over square root M1, which is hydrogen, that is 2, which is equals to T2. We are looking for T2, and we are giving T1 to be 1. If you look at this now, we want to remove the square root. Just square the both sides, square both sides. Then we are left with 32 over 2 is equals to T2 square over 1 square. So our T2 square now will be 32 times 1 over 2. T2 square will now be 32 over 2, and that is what? 16. So our T2 now will now be square root of 16. And what is the square root of 16? Square root of 16 is 4. So our T2 is 4 seconds. So going back to the option given, our option A is 2.5. So this is wrong. Option B is 4.0. And our T2 is that we obtain is 4 seconds. This is the correct answer, 4 seconds. I hope you got value from this question. Stay tuned next time on this same channel, Helizchem, where I'll be bringing you more questions can come out in your WAEC or JAM. Bye.